Hello students, welcome to online lecture series of discrete mathematics. So last lecture we have studied what is this principle of inclusion exclusion theorem. So today we will see some examples based on this principle of inclusion exclusion theorem. Right. So question is, a large software development company employs the 100 computer programmers. Of them, 45 are proficient in Java, 30 in C Sharp, 20 in Python, 6 in C Sharp and Java, 1 in Java and Python, 5 in C Sharp and Python, and just one programmer is proficient in all three languages. So question is, determine the number of computer programmers that are not proficient in any of these three languages. So for this example, first of all, what is the given data? So in given data, what is the universal set here, right? So whatever your this rectangle, right? So value of this rectangle is, that is 100. So number of employees for that company is 100. So this U equal to 100. Then the Java, the 45 are proficient in Java. So we consider a J, right? That is J, C, and P denote the set of programmers proficient in Java, C Sharp, and Pythons respectively. So this J is equal to 45. C, that is C Sharp, we consider a variable that is C. So 20, sorry, not 20, that is 30 in C Sharp and Python, right? So 20 employees are proficient in Python. So that's 6 in C Sharp and Java, 6 in C Sharp and Java. Then 1 in Java and Python, and 5 in C Sharp and Python, and one programmers that is proficient, that is J intersection C intersection P is equal to 1. So there are three sets are there, 1, 2, and 3. Right. So here, whenever we draw the any Venn diagram, right? So here, which part we have to find out here for this particular program? So here we have to find out this outside part. This outside part. This one. Outside of this, all three circles, right? And that is in a rectangle. So rectangle, value of rectangle, that is universal is 100, right? So first of all, we have to find out this value of this all circles, that is those who are proficient in all three languages, right? Right, proficient in three languages. So this whole part, first of all, you have to find out. So here, so this is the Venn diagram. So it requires three circles since three sets are involved. So big. So here, so total GR 50, right? So 45 minus, so whatever Venn diagram is drawn here, right? So here we find out each and every part of that circle separately. So here middle part, who know all the three languages, that is 1, right? So using that, this, if whenever we know this part, this middle part, then we can find out this part also, right? Again this part, add this part. Right? So here we have to find out this outside part. Right? So here. So what is the principle of inclusion exclusion theorem? That is J union C union P is equal to J plus C plus P minus J intersection C minus J intersection P minus C intersection P plus J intersection C intersection P. So using this formula, we have to find out this area, that is this one. So using this principle of inclusion exclusion, we can find out this whole area. Right? So J union A, C union A, P is equal to 84. Now the calculate the complement, because here we have to find out the outside part of that three circles. So we know the rectangle, that is 100, right? So 100 minus J, that is J union C union P, that is 100 minus 84, that is a 16. So 16 programmers are not proficient in any of the three languages. So this is your final answer, that is a 60. Next question. So it was found that IT, right? The first year of IT students, that is 80 students, 50 know COBOL, 15 5 know C language, 46 know Pascal. It was also known that 37 know C and COBOL, 28 know C and Pascal, 25 know Pascal and COBOL. 7 students know none of the language. 7 students know none of the language. So find how many know all three languages, how many know exactly two language, and how many know exactly one language. So first of all, you have to write down the given data. So here, first we have to assume the variables for these three different languages. So A be the set of students who know COBOL, B be the set of students who know C language, and C be the set of students who know Pascal. So here, this U, here value of U is here, total number of students are 80. So U equal to 80. So A, who know COBOL, that is equal to 50. Then who know C language, equal to 55. And who know Pascal, that is equal to 46. So intersection of this COBOL and C language, that is 36, 37. Intersection of this COBOL, C and C language and Pascal, that is 28. And COBOL, intersection of COBOL and Pascal, is 25. And here A union B union C bar, that is equal to C. Here meaning for this 7 means what? This 7 is nothing but whatever these three circles are here, right? So this outside of these three circles is nothing but your 7, right? So this A union B union C bar is equal to 7, U is equal to 80. So here we have to find out who know at least one of the language. First of all, we have to find out who know at least one of the language. So how to find out this? So total number of students, that is 80, minus who know none of the language, right? So number of students who know none of the language, that is 80 minus 7. So that is equal to 73. Who know at least one language. So first question, who know all three languages? Right, here we have to find out who know all three languages. So this part is your 7. Sorry, not 7. You have to find out this part. Who know all the three languages? You have to find out this part here. And this outside part is this. Inside the rectangle and outside the 3 circles. This part is a 7. Right? So here, as per principle of inclusion exclusion theorem, that is A for 3 sets, A union B union C is equal to A plus B plus C minus A intersection B minus B intersection C minus A intersection C plus A intersection B intersection C. So just write down the values of all this Pascal, COBOL, right? Write down the values of all the variables. That is A union B union C, right? That is equal to 73. So 73 equal to 50 plus 55 plus 46 minus 37 minus 28 minus 25. And here we have to find out this value, that is A intersection B intersection C. Here we have to find out this value. So this A intersection B intersection C is equal to 73 minus 151 plus 90. So that is A intersection B intersection C equal to 12. So who know all three languages is equal to 12. Is equal to 12. So next, second question. Who know exactly 2 language? Who know exactly 2 language? Means here we have to find out this part. This one. Here, this one. And here, this one. So here we can directly find out by using the Venn diagram. So for here, COBOL and C language, these 2 language known by how many students? That is 25. Then C and Pascal, that is 16. And COBOL and Pascal, 13. So just you have to perform the addition, right? That's 25 plus 16 plus 13, that is 54 who know exactly 2 language, right? The next question, there is last question, that is who know exactly 1 language. So exactly 1 means what? We have to find out this part. We have to find out this part. So by using Venn diagram, right? Right. So this part is 0, this part is 2, and this part is 5, right? So total for this A, total value of this A is 50, B is 55, and C is 46. Just we minus this 25 plus 12 plus 13 from this 50. So we got 0. Same here, 55 minus in bracket 25 plus 12 plus 16. So we got 2. Same here, 46 minus 13 plus 12 plus 6. We got 5. So this part, whatever colored part is here, right? This part is the who know exactly 1 language. Just we have to perform the addition. There is 0 plus 2 plus 5. There is 7. So 7 who know exactly 1 language. So in next lecture we will see the next part.